The file name is called Sigma Render Manager Core, and then we have another file called Sigma Render Manager, which inside of it contains a file called Sigma Render, or contains an instance of the Sigma Render Manager Core class. And this file right here, Sigma Render Manager, if I remember correctly, it has a method called subscribe. And subscribe, it literally, so it subscribes to an object that is of type iSubscribable. This is new stuff we haven't done with this yet. Sigma Render Manager is of type iSubscriber. Sounds all great, except for things. Yeah. Inside of Sigma Render Manager, we have an object called Sigma Render Manager Core. This object is going to be of type Sigma Sigma Render Manager Core. And what subscribe does is let's see.
All right, let's go to Sigma. What time do you want to go to? 10:10?
Yeah.
Hard cutoff?
Yeah. That's right. Okay. Let's see. I was looking at our file. This is just Render Manager.
Okay.
Render Manager Core. So, Render Manager. Will. Oh, okay. Gotcha. All right. So we have some object somewhere. Okay, I'll give it another minute.
Okay.
All right, so here's our class Render Manager. when we create an instance of it by saying something equals new Render Manager, new capital Render Manager,
yeah.
I bet you that the variable we're calling it, that this equivalent, is going to be called lowercase Render Manager. That's just like the naming convention I have.
Okay.
And nope. All right, so we need to look for things with the type iRender Manager. Is this it? All right, rendered nodes render. One of these days I'll clean all this shenanigans up. Okay. So rendered node
rendered nodes manager. Why do we call it that? Why don't we call it something else? I'm gonna rename that to what is that type? Is it I render manager? Oh, here. Ooh, that's smart.
Look at this is a teapot.
Yeah. I took it from the.
Physical.
But there was dust in it. Oh shoot, that's coming out. Okay, well that's good enough right there.
All right.
I took it from the physics lounge. No, there was dust in it though. I had to wash it out.
Yeah.
That's what justified me stealing it. I'll bring it back.
All right. So I have a naming inconsistency.
Mm-hmm.
So notice how sometimes I have class and then class core, I have rendered manager and then rendered manager core.
Mm-hmm.
So here I have I render manager core, but then rather than calling the parent I render manager, I have it called I rendered nodes manager.
Mm-hmm.
So it's I'm just going to rename. All right. So Command Shift H is global replace.
Mm-hmm.
So rather than calling I rendered nodes manager that, I'm just going to call it I rendered manager.
It's some consistent naming. It's so nice that you could just do that. Universal replace.
Yeah.
Command H is universal replace.
Yeah, Command Shift H. Oh, it's I rendered. First I'm just going to do global search. Okay, I rendered nodes manager. All right, it shows them essentially 1, 2, 3, 4 files. Don't worry about the build file. It's made later. Did this not replace? I think it did replace. No, it didn't. How do I finish? I've actually never done a global search and replace in Visual Studio Code. It's not finishing. Oh, need to hit, what does it mean? Shift Command 1. There we go.
For each one?
Yeah, so see how when I mouse over it, it says, yeah, replace all, Shift Command 1. Like that. Replace all, Option, Command, Enter.
Nice.
Okay, so now I have consistent naming. Alright, so what was I saying before? We have an object called render manager, which is going to subscribe to some object that publishes iSigma render updates.
Mm-hmm.
The way we know that is that object is a type iSubscribable. So that's a type that we've defined that says whenever that type gets modified, it's going to publish an update that can be subscribed to.
Mm-hmm.
Or rather, the object can be subscribed to. With the object that's subscribing it uses that object's. Object 1 subscribes to object 2.
Mm-hmm.
Object 1 has a subscribe method,
Mm-hmm.
and object 2 is subscribable. And the way they
Mm-hmm.
subscribe is by one calling subscribe on the other.
Mm-hmm.
And that happens
inside of this file, app container. This is like the very root file of the entire application.
Mm-hmm.
So rendered. Why is it still called rendered nodes manager? Oh, we never replace this one. What? Oh, what am I doing? Hit the wrong button. How do I replace in one file? That does not do it. All right. So Control H and Apple F. Try and move this.
Install, right? Just click X. I don't know. It's annoying.
There we go. So we're just renaming rendered nodes manager to. No, we can keep it called rendered nodes manager. No, we'll rename it.
Rendered.
Yeah.
Does that really mean like actually like the rendered actual nodes in the actual application or no?
I'm not even sure off the top of my head. I'm gonna try. Let's just call it render manager.
So you're changing render nodes manager, or should it be rendered nodes?
Well, I'd first change it from rendered nodes manager to render manager. That would change from render manager to render manager.
Okay.
Render nodes manager. All right, so here we go. Our render manager class subscribes to Sigma render manager.
Mm-hmm.
So what that means is that our class that is giving us the update is Sigma render manager. So we need to make Sigma render manager publish us the right updates. And whatever we call Sigma render manager, we need to give publish right updates. Okay. So what is this? Okay. So remember how the other day we added another type, or we added a property into iSigma render update called Sigma ID,
Mm-hmm.
and how we added a new render update type called remove node
Mm-hmm.
and remove edge. So what we need to do now is inside of this class, Sigma render manager,
Mm-hmm.
we need to add a case statement for that new render update type. So we have to
So, yeah.
case render update types.
For both
drop-
of them?
Yeah.
Both of the new ones?
Well, just for drop node for now.
Okay. No, wait, no. I'm trying to
It's,
do remove
called
node.
Yeah, just backspace and hit dot, and it'll give you all the options.
Remove node. Okay, and then is that it? Well, type this.
Yes, but we're not when you pass in a different property in our update object, and that different property, it's not going to be Sigma Edges ID, Sigma Edge IDs to render. It's going to be called Sigma ID.
Okay. What? Because underneath the, is that because underneath the remove node, it's wherever it was. It's this.
We added the optional property Sigma ID is going to be essentially not optional when our type is remove node.
Okay.
Yeah.
And is that what this says right here? Or no?
No, actually, we don't make types. We don't make an interface such that it will error out if Sigma ID is not present and the type is remove node.
Mm-hmm.
Do you follow that post?
Say it again.
Ideally, we would make TypeScript error out if type in this interface were remove node and Sigma ID weren't present. But that would be kind of complicated. We're just going to pass on that for now.
How do I go back to where we just were?
We were in Sigma render.
But you know what I'm saying, the shortcut.
Yeah, try Control minus.
Control minus. Yeah. Okay.
All right. So we need to get the Sigma ID, essentially the ID of the node. That's what Sigma ID means.
Yeah.
That we are removing. And scrolling down, where do we get that from? Is that under update type? What is render update type? Gotcha. Update. Okay, so if you click on the iSigma Render Manager interface or just hover over it, the interface has three main methods. It has mark tree data loaded, has mark tree location data loaded, and it has something called add waiting edge. That means, so when this class, Sigma Render Manager is used when we're downloading stuff from the database. So let's draw some terminology. So we'll say that when we draw a circle on the screen, that means that hover over that again.
This?
Yeah. All right. We'll say that when we draw a circle for a particular tree ID, let's say this is tree ID 345, we draw a circle, we'll say that signifies that mark tree location data loaded has been called. Okay. That's one of the three methods.
Sorry, I'm trying to see if this can see you. Okay.
Yeah.
I just want to make this really small so that we know that what's on the screen. Okay. Okay,
so when we draw a circle, we're saying that represents that mark tree location data loaded has been called.
Okay.
When you fill in a circle like this, we're going to say that marks that mark tree data loaded has been called.
Okay.
Because remember, in our database, we have multiple different sections. One of the sections is for the tree data, like what is the tree's parent ID, what is the tree's content, what is the tree's children. And then another is for the tree's location data. Like what XY coordinates the tree on, what map is it on.
And then what's waiting edge?
That's the line. Yeah. So let's say over here and over here. Okay, let's say this is the parent of that. And this is the parent of this. Well, remember, when you draw the circle, it means the tree data has been loaded. What is contained in tree data?
The location.
Tree data is parent ID.
Okay, parent ID.
Content ID.
Content ID.
And children.
So yeah, in Say this again. This is the
This
tree
is
data.
circle is tree data,
Circles tree data.
and then wait, which way did I say it?
Let me put it on paper.
Yeah, circle means tree data, and then filling the circle, we're gonna say that means tree location data was loaded.
Okay. So, open circle is
Means that the tree data has been loaded.
tree data loaded.
Filled in circle means that the tree data has been loaded, and the tree location data has been loaded.
Tree data and tree location.
Yeah.
And then the circle, what's the next one? Is it just with a line? Or is there, never mind. Okay, and then within the tree data,
There are 3
there's tree ID, right?
Actually, no, there's just parent ID,
Parent ID.
content ID, and you tell me.
Lowercase or uppercase I and D?
Uppercase I, lowercase d.
Yeah, okay. Parent ID. Content ID? Is that what it was?
Yeah.
Second one? Is this the last one children?
Yeah.
Or is it children ID?
It's children.
Okay. And
So,
then in the tree location, there's
for now, just think of it
X
as
and
two
Y.
properties. There's something called point,
Point.
and point itself contains 2 properties, X and Y.
Okay.
And then there's another property called map ID.
Okay.
All right. Anyway, so let's say we've had this before.
This is the parent. This is the child. Yeah. Okay.
So let's say that some nodes tree data has been loaded, and we have access to its list of children, and then we've also loaded the tree data for one of those tree's children. Well, the location data hasn't been loaded for either of them yet. So we have this edge.
This is a line.
Yeah, this line, which can't be drawn yet because we don't know the location. So I think what this add weighting edge method does, and I don't remember, is that it draws the edge. But we don't call that until the 2 nodes have been loaded. I don't really know. We don't need to know. We don't need to know what the method is now. But anyway, what we do need to know is we probably need to add a method into the iSignal Render Manager class called like mark tree removal, so that we can remove it from the screen. We need to figure out what calls Sigma Render Manager. So I'm going to Control-Shift-F for Sigma Render
Like all the things that call Sigma Render Manager, or is there only one thing that calls Sigma Render Manager?
Well, here we go. So there's a class called Sigma Nodes Updater. Yeah, this whole render system's super complicated.
It's cool, man.
Okay, so we have a class called, is it called Sigma Nodes Updater?
Yeah.
Yeah. Sigma Nodes Updated calls this class. And it does that by type and ID and val update. Highlight node, unhighlight node. Well, what is What is this interface? Sigma nodes updated. Has handle update, highlight node, and unhighlight node. Val update. Let's look at iType and ID, val update. Alright, so this class right here, it's called Sigma nodes updater, implements this interface. This interface has one main method and two secondary methods. The main method is called handle update. Let's look at handle update. Handle update gets essentially the nodes that are effective update using this method, gets the Sigma IDs. And then it looks at each Sigma ID and calls update Sigma node on that ID based on the update. Alright, so we have a property called update type, property called data.
What is and? Ampersand?
That's for it's for like combining types together. I don't even know how to describe it.
Okay, don't worry about it. Don't worry about it.
I'm curious. It essentially says that this type.
Mm-hmm.
Oh man, we just searched this the other day and I forgot already. Yeah, but it's something called intersection type. And they barely even describe it. But I think what it means is that we create an interface called object data types, which takes all the properties
Of all those?
of those types and bashes into one massive type.
Yeah, okay. Makes sense.
Okay. Right. Okay. Okay, so I don't really think we should edit this class.
Okay.
The purpose of this class is to update a node that already exists. So the only update types it's taking is
Add and new.
not add a node, just really modify.
Okay.
Just kind of modifying the data on a node. So,
But is this for when nodes are created, or when like maybe more children are created, or
no, this is just for
when the data is altered in a node?
Yeah.
Okay.
So if we were trying to modify this class to do deletions as well, it'll like make the class too big.
Yeah. And this is when we're saying node, these are nodes.
Yeah. So let's find what calls Sigma nodes updater.
Now, how do you know that it calls it?
You'll see some file that says you'll see some line of code that says Sigma nodes updater dot whatever, like dot some method name.
Okay. And that means that the method calls.
Yeah, like
Okay.
all right. So we have a method on Sigma nodes updater called handle update.
Mm-hmm.
Um,
Does this method call this? This method called Sigma node updater?
no, so Sigma node updater is the object.
Yeah.
Handle update is the method.
Yeah.
So
And so the method calls the object?
No, the method is called. The method is called. And the method is part of the object. I guess
Okay.
that was described as an example. Remember how we had like some car name, car base car. Dot accelerate.
Yeah.
We say that the method was called, and when it's called, it modifies the behavior of the object.
Yeah.
But we don't say that the object was called.
Okay. Yeah. Yeah. Makes sense.
Yeah.
Okay.
Okay. So okay, so Sigma nodes updater, it is called inside of a class called canvas UI.
Mm-hmm.
Individual. Right, so we said render manager calls render manager core, right? One day this.
Now, render manager, this is a method.
That's a class
Okay.
that has two methods.
Okay.
One's called
Okay.
render. Oh no, this is the property. Okay. And then this is the method. Cool.
And I know it's a method because it has
Rest of these, yeah. Alright, did we say, what did we say calls, what was the relation between Sigma and manager and
Sigma render manager and Sigma and what was it?
and render manager?
There's so many names.
You
I don't-
just
I
go
don't-
back in the video and watch it. You
No,
do it.
let's go back here.
Okay. Go back in time.
I think render manager. Subscribes to Sigma render manager. So,
Okay.
Render manager.
Okay.
This is different terminology than our branches have. Dotted line means subscribes to.
Sigma nodes updater. What did we say that? Sigma nodes updater. We said that Sigma nodes updater. It does it subscribe or does it what does it do? It calls methods of nodes updater. Dot. It has an instance of Sigma manager. Sigma manager dot. Really lost. We have we'll go to the Sigma Nodes updated class.
Okay.
It's this big class right here. It has an instance of Sigma Render Manager. That's right. We have a property called Sigma Render Manager. So this stuff Sigma Render Manager is something we pass in the constructor. And we use that. So we'll say solid line means contains an instance of and uses.
Okay.
Sigma Nodes Updater, it contains an instance of Sigma Render Manager, and it uses Sigma Render Manager. Canvas UI contains an instance of Sigma Nodes Updater. This Sigma Nodes Updater equals, and it uses Sigma Nodes Updater because it calls a method on Sigma Nodes Updater. It calls handle update. Sigma Nodes Update Canvas UI contains an instance of and uses Sigma Nodes Updater. So our Canvas UI is supposed to be meant to represent our entire UI. And what it's supposed to do is subscribe, I think, just to our store. Let's see. Okay, so we have this file, we have this method in Canvas UI called subscribe. I'm wondering where that method ever gets called. Let's find all references. Studios. Not intelligent. Alright, there we go, it's app2s. Alright, so inside of app2s, we have all our UIs. One of our UIs, and you can't figure it out through this file, is our Canvas UI. Later we might have more UIs, and we'll have like an Alexa voice UI or something. But right now we just have our map. It's called the Canvas UI. The map means canvas. We call give battery. I don't know if you turn on the battery. All right, so on this line right here, for all of our UIs, one of which is our Canvas UI, we subscribe to the store. The store publishes certain types of updates.
And when those updates are published, if it's subscribed to the store, then this takes the updates. Then this would like, the store gives this, or it like would read the updates from that or whatever, or no?
Yeah. Well, the store doesn't need updates. The UI should read from updates and then update itself. What type of store? Store is a type immutable, subscribable, global store. And okay. All right. Okay. So our store.
You remember what the store is. It's literally just a list of all the tree data objects. It's a list of all the tree locations.
Mm-hmm.
It's a list of other stuff as well. Or it contains files. It's a list of all the tree data, so it's all the tree
Mhm.
locations.
Mm-hmm.
And it publishes an update whenever one of the items in those lists gets modified.
Mm-hmm.
Does it publish an update? I think it does. It does. Val update. So the type of update getting published to us is of type iType in ID and val update.
Mm-hmm.
That means it's going to have one property called type, which means it can be either that we're updating the tree data, the tree location data, tree user data, content data, content user data.
Mm-hmm.
And then it also contains properties ID and val. I don't think our app is really set up to be able to remove a node easily.
You're realizing that now.
Yeah.
That's cool.
So we'll have to add something.
Do you mean there's like you have to do a lot more stuff to do it?
Some amount of stuff. I mean, you can do it.
Yeah.
So that'll be fun.
What do you have to do?
I think we have to. I don't know yet. I know we can't do it.
Yeah. Yeah.
Alright.
Well, I mean, we could do anything. The world's our oyster.
Good attitude. The issue is that the updates being provided by our store
Mm-hmm.
don't provide enough information to us. They just tell us that there's totally a new value of the object.
Mm-hmm.
So let's say tree data
Yeah.
had children updated.
Uh-huh.
Well, it's just going to give us the new value of everything. It's going to say parent ID is now this, even if it's the same.
Yeah.
It's going to say content ID is this, even if it's the same.
The children IDs are.
Yeah, but it doesn't. It tells us all the new values, but it doesn't really tell us what has changed. So if it just so happened that one child was removed, we want to know that. It's just kind of saying like it's like if you were to ask your friend what's in the fridge,
Yeah.
you tell you the exact current state of the fridge, what's in there, but you would have no memory of what was there before.
Yeah.
So like if you knew that someone removed an orange from the fridge,
Yeah.
well, you want to know that someone removed an orange from the fridge.
Yeah.
Unless you kept track of the previous state, but we aren't keeping track of the previous state.
Mm-hmm. Now, what is wrong with keeping track with? What is wrong with not knowing what was there before?
Because the update we're receiving is just an update of what's in the fridge. It's not like we need an update that says we removed this node. We need an update that says we removed it.
So that the UI knows to take it away?
Yeah,
Because if not, the UI will not take it away.
correct.
It'll just kind of update with what's there. And so the UI will update with what's there, but even though
It
that
won't even
this thing...
it won't even update with what's there.
Oh, okay.
This is meant to change current values in the node. Like we have, so inside of each node, remember we have a bunch of data. And then when you click on the node, it draws up this box.
Yeah.
The color of that box gets changed when like data here gets changed.
Yeah, okay.
Or the location of the node gets changed, the tree location gets changed.
this.
Yeah. I was trying to connect this issue with. Is this connected to the issue of when we try to delete one of them, everything but what we deleted?
Nah, it's totally another. Yeah, this might be something I have to think about for a while, and having to
Yeah.
explain it the whole time would kind of be hard to do.
Yeah.
So it might be good if you just review something while I think about this.
Yeah, that's okay. Yeah. It would take way too long for you to explain everything, your whole thought process.
Yeah.
Okay. And if you need to sleep on it, it's cool.
No. It's something I could figure out today.
Okay.